Hello, so in this class, you guys learn about a couple of new things. First one is parallel circuits. Usually, a series circuit or a simple circuit that you've seen before is something like this, where there's a battery and there can be one bulb or more than one bulb. For example, you can have one more bulb like so right here, and these are called series circuit. And sometimes they're also called simple circuit, but usually simple circuit is when you just have one bulb and let's say one battery. And then whenever I say bulb, it can, I mean, that bulb can be something else, for example, a buzzer or a motor as well. So we usually work with bulbs, so that's why I use bulb. But that can be any electrical component. So that is the series circuit. A parallel circuit, as the name dictates, is a circuit where two entities other than the battery, two electrical devices here, these are two light bulbs. They are in parallel. They're in a parallel in a way that, you know, imagine this wire coming out of this bulb and this wire coming out of this bulb, and they converge and they become a single wire coming out of the battery. The same thing happens the other side. That's how you know they're parallel, at least by looking at them. But sometimes just looking at them is not enough. So this is, excuse me, this is not. This is an example of a series or a simple circuit and a parallel circuit. I'm just gonna remove everything extra just for a second, and it looks kind of crooked. For example, let's look at the left one. I have a current meter here and a battery here. The battery voltage is 9 volts. The battery is powering this bulb, and the current that is in the circuit is 0.990 ampere. So this is a case of a simple circuit. A simple circuit or series circuit when let's say a bulb is powered by a battery. One thing is pretty clear, in the wire the current is the same. The current that is here is same as the current that you see in the series circuit. In a parallel circuit like this one, the first difference is that, let me show you in a first in a picture. So the what's happening here is if you try to follow the the water or the current, the flow of electricity coming out of the battery, as it reaches this point, some of it goes this way, some of it goes this way. And on the other side, whatever is coming out of this bulb, whatever is coming out of this bulb, and they become one, and then you see a current here. That's what I'm trying to show here. So this is a case of parallel circuit where this battery is again 9 volts and 1.80 ampere is being supplied by the battery. 0.90, that is half of it, goes into this bulb, the other half goes into this bulb, and then the same current combines at this point, and then that goes into the circuit. Let's measure voltage here. So this is a simple circuit. We know the battery voltage is 9 volts. Let's look at the battery, not battery, but the bulb voltage. It is 9 volts. So 9 volt is being supplied by the battery, which is exactly what you see across this light bulb. For this case, let's say the battery voltage across this one, it is 9 volts. Okay, and also this one will also have 9 volt battery, or the voltage difference, and the battery is also 9 volts. So what you have here in this circuit is, in parallel circuit, the voltage is being shared, and in a series circuit current is shared. That's the difference between parallel and series. The next thing you see in this class, this is class 5, is the introduction of resistance, or resistors I should say. So resistors are electrical devices which provide resistance to the flow of electricity. So those things are called resistor. A resistor is shown by this symbol in a circuit. So if there is a resistor, what it does is it obstructs the flow of electricity In other words, it decreases the current. So here I have a simple circuit, and here this thing right here is the resistor, and the resistance is 0 ohms. It is as if there is no resistance at all. Okay. Watch what happens, and the current, note down the current. Current is 0.90 amperes. So watch what happens if I increase the resistance. So this would be as if I'm replacing this with a higher resistance value resistor. And when I'm doing this virtually, all I have to do is just move this slider to a larger resistance value. As you can see, the brightness is like the bulb is getting dimmer and dimmer, and the current through it is getting smaller and smaller. If I increase it too much, eventually the current gets so small that almost the bulb is not lighting at all. And when the resistance is really small, the current is really big and the bulb is really bright. So that's the whole point to resistors. The next in line is more complicated circuit. So more complicated circuit can be a circuit that you see on the screen right now, where you can't really say that this circuit is a parallel circuit or this is a series circuit, because yes, it is true that, like, first of all, what happens, the current goes through bulb 1, gets divided into 2 and 3, and then recombines here. But because it goes through bulb 1, which is not just a simple piece of wire, but which is electrical component. What should you say in this circuit in order to describe this is that the bulb 1 is in series with the combination of bulb 2 and 3. So this can be visualized, just for your understanding, as a circuit where this is bulb 1 and this is some combination of bulb 2 and 3. So it is true that bulb 1 is in series with the combination of 2 and 3, and the combination is the parallel combination because they share the same voltage. The current gets divided between the two, and that is a parallel combination of 2 and 3, which is in series with uh, the light bulb 1. And I've shown that exact circuit, this one right here. So as you can see on this one, you've got 9-volt battery, that's 9-volt battery, and the current delivered by the battery is about 0.6 amperes. This bulb is the brightest because this gets all the current, that is 0.60 ampere. Okay, let me get rid of these voltmeters for now so that we can look at the circuit, understand what's going on here. So if you look at the current, half of it goes through this light bulb and half of it goes through this light bulb. The reason half, the division is half and half, is that the both are the same kind of light bulbs. Now, for example, let me give you an example here. If this was light bulb and this was a buzzer, then it would not be true that 0.30 would be coming through this light bulb and then 0.30 will be coming through this buzzer. It is just because these two light bulbs are of the same kind and they both are light bulbs, the current division is equal. But it is always true that in a parallel circuit, as we learned, the voltage is the same. So if I measure the voltage across this light bulb, that is 3.0 volt, and the voltage across this light bulb is also 3 volt. So that means this light bulb and then this light bulb, which are light bulbs 2 and 3 in the diagram, they are in parallel. Okay, and the combination of those two is in series with this light bulb, because those two like when you combine, they have current 0.6 ampere and this guy also has 0.6 ampere. Let's for funsies just measure the voltage across this one. The voltage across this one is 6 volts. The battery is 9 volts. So it's out of 9 volts, 6 volt is across the first light bulb. That's why it's the major chunk of the voltage is across the first light bulb. That is why it is shining the brightest. These light bulbs, they have 3 volt and 3 volt across them. So as you can see, if you add this is how the voltage division actually happens. So across, if this is 9 volts, then across this is 6 volt, and across these two is 3 volt. So 3 volt across the third light bulb and 3 volt across the second light bulb. So in total, the voltage difference here is about 9 volt, which is what the battery supplies. So that is an example of a more complicated circuit.